Have you ever looked at the night sky? On a clear dark night, when you look up, thousands upon thousands of twinkling stars greet you. The space seems deep and vast. And then you wonder about the scale of the universe. The universe is big, but exactly how big is it? Humans have wondered about this for ages, and just over 100 years ago, astronomers set out to answer this very question. The year was 1920, and the size of the universe was one of the main questions that scientists were grappling with. So, the National History Museum in Washington, D.C. hosted a debate between two famous astronomers of that time, Shapley and Curtis, to settle this exact question. This was called the Great Debate. Here, Shapley argued that our galaxy Milky Way, which in his estimate was about 300,000 light years across, is the full extent of the universe. Curtis, however, opined that the faint cloud like structures in the night sky, which are called nebulas, they are not inside of our galaxy. Rather, they are other galaxies, which he called other island universes. This was quite a revolutionary idea at the time, because till then no one had any observational proof that such faraway objects existed. The result of the debate remained inconclusive until a few years later, when another astronomer, Edwin Hubble, actually observed these distant nebulas and proved that they are indeed other galaxies besides our own. Within the next few decades, many other galaxies were observed, and it became clear that our Milky Way is just one among numerous galaxies in space. In current estimate, there are about 1 to 200 billion galaxies in the universe. The vastness of the universe is difficult to comprehend. Our brains are not good at fathoming really big numbers. The cosmic distances are so vast that the normal units of distance, like kilometers or miles, they don't cut it. So here we measure distances in light years. Light is the fastest moving stuff in the universe. Within the time it takes you to blink, and one blink takes about half a second, light can complete the journey around the whole Earth 4 times within your one blink. A plane traveling at 900 kilometers per hour, it takes about 2 days to go around the Earth just once. At a speed of about 300,000 kilometers per second, light travels 9.5 trillion kilometers in 1 year. The same plane that we talked about, it will take 1.35 million years to cover this distance. And how long is that time? About a million years ago in Earth, there were still no human or Homo sapiens species. Our early ancestors, the early hominids, they were just walking upright and exploring. So if our plane started out then, only now it would complete the distance of 1 light year. And what if we use very fast rockets instead of a plane? The fastest rocket ever made is the Parker Solar Probe that is currently flying towards the Sun, and it has achieved a blazing speed of 163 km per second now. At this speed, this rocket will take 1839 years to travel 1 light year. That is indeed much faster than our plane, but it is still a very long time. What was the world like 1800 years ago? The Roman Empire was at its peak in Europe, and the Kushan Empire was flourishing in India. Christianity was flourishing in the West, and Buddhism has started to spread in the East. If our rocket started out then, only now it completes the journey. So that's only one light year. Our nearest star and the nearest exoplanet is 4 light years away. So traveling to other stars and galaxies still is a distant dream. But what if we could fly at any speed we want? What would we see? Let's start that journey and zoom away from Earth. We begin from the city of Kolkata. Zooming out from the Howrah Bridge, we reach the skies. Gradually, we can see the Ganges River and its tributaries, the Bay of Bengal, the Himalayan mountain range, and finally, the entire Earth. Now we venture into the space. There is the moon, our closest and constant companion. Farther out, the sun shines brightly. At 150 million kilometers or 8.3 light minutes distance, the Earth is situated just right. It is neither too hot nor too cold. This comfortable climate has allowed life to flourish here. Here we see Mercury, Venus, Earth, and Mars, the 4 rocky planets that make up the inner solar system. The gas giant planets that make the outer solar system, that is Jupiter, Saturn, Uranus, and Neptune, are much, much further away. We have started our space journeys about 60 years ago now. The farthest that any human-made object has reached is a satellite called Voyager 1. Flying for 45 long years, it has now crossed the edge of our solar system and is peering into the interstellar space. The interstellar space is a sea of vast, inky darkness. Even light takes years to go from one star to another. Leaving our solar neighborhood far behind, now our galactic surroundings become clearer. Our Milky Way is a spiral galaxy. It is shaped like a disk, and we are located at the outskirts of it. Our galaxy alone contains about 100 billion stars in it. In the distance, we see our nearest neighboring galaxy, Andromeda. These 2 galaxies are moving towards each other and will collide in about 4.5 billion years. Milky Way, Andromeda, and a few nearby small galaxies make up the local group. There are billions upon billions of galaxies out there in the universe. But they are not distributed completely randomly. On a large enough scale, we find that galaxies like to stay in big groups. We are part of the big galaxy supercluster called the Laniakea. There are many such superclusters out there, and together they make the cosmic web. Each bright point here is a galaxy. This web is a simulated map of our universe. The Planck satellite observed this map in a different form. It observed the temperature of the oldest light in our universe, the afterglow of the Big Bang. It found that although the temperature is almost same everywhere, there are minuscule differences, as you see as difference in the color in this map. These differences later become seeds of our current galaxies. So finally, we have reached the border of our universe. We call this the observable universe because since the Big Bang, light has had time to reach us only from this far. The size of our observable universe is 93 billion light years. What is there beyond these borders? Even more galaxies? Galaxy clusters? An infinite universe? Or are there other universes? We don't know that yet. If you like this content, Please like, comment, share, and subscribe. Thank you very much for watching.